This is Mario with MIM Microflight, and once again I'm working on these train trucks. I've been playing around with the design of these plates here, these side plates, which would be the bearing supports for the wheels, and I finally lucked up on this particular design here. In my previous videos, I talked a little bit about the how I wasn't happy with the aesthetics of this particular truck here, because it was taking away from the aesthetics of the locomotive. If I can locate this right here, it doesn't have the wheels, but that would sit like that. I mean, it depends on your taste, I guess. But I really like this white one, the way it was contrasting with the dark spacer block inside and the wheels, dark wheels. And so when I did this one, I wasn't happy. In addition, it has a space between this portion right here, this block, as well as the outside plate with the surface of the bottom surface of this locomotive bottom plate. So I wasn't happy with that. And you'll notice that in this particular one, I designed this way to have a little bit of suspension. That's what that curve, open curve, open slatted curve is was for. It really doesn't have any real bearing, because this would have to be a little bit heavier. I didn't want to go too thin here on the material for my spring action, because then you risk breaking the part. So that was about the limit that I was going to go. But it really doesn't really affect it. Doesn't do very much, and it's more for aesthetical purposes. So I wanted to do something between that, and I came up with this particular design here, which still maintains this upside down V. Typically, these side plates or side structures on the real trains, they have the V going downward. You know, this portion right here where it holds the springs, the suspension. And so on mine, when I did this one, I purposely inverted it because I wanted to do something different, and I really like the way that looked. However, I wanted to, I thought I could make it better, and so I went to the second iteration, and finally I arrived at this one right here. You'll see how nice this one looks. I also added a border here. That's about a 40 millimeter wide border, just to frame this a little bit better, and so it's not just flat as this part is. It gives it a little more depth, and from an aesthetical point of view, it enhances the features of this locomotive here. You'll see how that looks once it's there. You see that? I mean, look at the difference between this one right here. And I decided to maintain my white plates here with the dark components, just to give it a little more contrast there. And so either one looks really nice, but I think I'm going to go with this one here. You know, just for the final locomotive assembly. So I'm working on that. Let me take this out again. So I want to talk a little bit more also on the actual parts here. Okay, so if you notice my wheels, I also angle the surface here on the wheel where it rides on top of the track. I angle those, so they're kind of angled like this and angled like that, and that's so that it maintains a minimal contact surface between the wheel and the track. So that it rides a lot smoother and a lot better. Also, the important is to have a little bit of play here between the wheel. So my wheels are free flowing. That's another feature of these particular trucks. From what I've seen, people build these things kind of quick and just with bamboo sticks and cardboard cabooses and locomotives, is that they attach the wheels to the axle. Both wheels are solidly attached to the axle, and the axle rides on these plates, which is something that is not beneficial from a mechanical standpoint, because when you have both wheels locked on at the same on the same axle, when you go on a turn, one wheel is actually wants to take a little bit longer travel than the other one. So having the wheels loose is a lot better, because that way you allow the inner wheel to turn, to turn first than the second wheel. So you got to have that you got to have the wheels loose in that respect, to allow that function, and so it rides a lot better. You can see on my curve here, it's really smooth. And so this is stuff that I've been working on as well. I should also mention that these ride on brass 3mm brass tubing here, and I just cut a bunch of them. So this is it's thin wall tubing. I think it's about 1 millimeter in thickness, wall thickness. These are 3mm brass tubings that I had from previous jobs. When I used to make the tiny little helicopters, I used to use 3mm brass tubing, and so I repurposed some of those leftover parts to make these axles here, and it's working extremely well. These axles are press fit into these side plates, so when the plate is fitted in a tongue and groove press fit setup here with the spacer block, it retains itself, number one. I could just use it as is, but I decided to go the extra mile and install these little washers, brass washers, with a screw, and so that washer and screw is going to go inside that little hole there to retain this, to clamp this thing, so it doesn't come out. It's not going to come out anytime soon the way it is, but that's another little added feature, just for added retention, and I think it'll add to the continuity of these metallic parts, just to balance it out a little bit better, so it'll look kind of like that screw. That's a screw from a servo horn, actually, that little screw that I put there. But this is a lot better, with the little washer there. So that's what I've been working on, just kind of cleaning this up, and I'm finally at the point where this is it. This wheel kind of printed a little weird on my I think this is I don't remember what the name of this machine is, but I have this little machine that I bought very inexpensively just to do quick parts and prototyping. And so I use this machine, and you can take out the plate on this one. It's not like my Anycubic i3 Megas, which are very nice machines, solid flat plates. This has a little bit of an imperfection on the leveling, I guess, because one of these wheels, this particular wheel came out. It looks like it started lifting on the corner here. I mean, I got tons of these wheels, that I've been printing quite a bit, so I can always replace that wheel. This is for the truck that runs loose, that needs to run loose on the either on the locomotive or on the just one of the box cars or additional cars. So it's very similar to these right here. So that runs free, and it's able to pivot free. So this runs through a bolt. These are 440 size bolts that goes right through there and attaches to a nylock nut, so it doesn't come out. The one for the locomotive, the one that drives it, I ended up moving it to the front of the locomotive here, just to distribute the weight a little bit better, because it was getting a little too heavy at the back. Actually, once you put the front one, I guess it really doesn't matter. But the idea with these locomotives is that you want to distribute the weight evenly between the center distance between the truck from truck to truck. So if you have a truck that's spaced out, say 4 inches between the center line of the mounting points, 2 inches should be the balancing point. But that also depends on how long the actual locomotive frame and structure is, because if it sticks out too much and it's heavier at the front, it's probably going to create an imbalance there. So the point is to balance that, at least in my perspective, is to balance that with the locomotive assembled, and find the balance point there, and that's where you want the weight distribution, you know, the mass, the center of mass to be, because then number one, you know, you're not consuming a lot of power, you know, to drive this, and it's a lot easier to push it, you know, forward. So when things are in balance and equilibrium, you know, things perform better. The truck for the motor drive is going to be similar to this guy here. The where is that? Yeah, similar to not this one. Similar to this guy right there, with one exception, that is, you know, unfortunately I don't have the white parts. Oh, I do have the white parts here. With the exception that I extended the this section right here to allow some clearance to insert a shaft. So this one will have a shaft through the front, whereas if I kept it symmetric here from wheel to wheel like these are, the one for the motor mount, you know, needs to be extended at the front to allow, you know, an axle to be fitted there. Otherwise, you know, the motor gets in the way of the axle. So it's something that I didn't take into account when I did these first tries, but I did take that into account when doing these new ones here. So that's why you see this portion here is a little bit longer than that section here, and that's to allow for an axle to be installed at the front, and so that it balances out with the back wheels, which are driven directly from the motor. This one doesn't have an axle here. I could put an axle, but it would have to be a very thin axle that goes right through this the wheel and the plastic axles that come part of the gear setup that's inside this little gearbox here. So I mean, I could go right through it. I think I could, but you know, it doesn't require. So I'm just leaving this floating here, and the wheels are also floating. As you can see here, they have a little bit of a plate here, and that is also on purpose, so that the wheels is able to go around corners, and is able to travel a little bit more free in each wheel. Although this is both driven by the same axle, it's a live axle, meaning that the live axle is connected to both wheels, and both wheels travel at the same rate. Unlike these wheels, that each wheel is independently able to turn freely on the axle, both front and back. This one on the locomotive is driven, both of them are driven through the gearbox right here. And so only this one right here, you can see here how I attached that with screws, because it wasn't long enough to allow for the axle that I'm talking about. But this new one here it does have provisions for that. So I'm about to assemble that with the gray block here, so that it looks like that one right there. So this is where I'm at right here with these parts, and I'm finally done as far as these parts are concerned. As far as the mechanical and aesthetical trucks, you know, for these for the locomotive. But I can also use those parts on cars like this one here. This is an open cart, or even something like this. You can see how I was using bamboo sticks here, but as I mentioned in my first video, when I did this, that wasn't my intention, you know, to maintain those bamboo sticks, because bamboo sticks, although they're good, you know, they're nice and quick to allows you to prototype things really quick. Bamboo sticks are not perfect. You know, it's not as precise as you know, precision type rod or a brass tubing. You know, tubing is very clean. Bamboo sticks have ridges, you know, on the edges, and unless you put that on a lathe and sand it, you're not going to get a precise outer diameter. And so, and this looks nicer too than with just bamboo sticks. So yeah, so that's as far as the trucks is concerned, the mechanical functionality and aesthetical looks of them. Next, I will be talking about some of the other parts that I'm designing for to make the connections here. I talked a little bit about my hooks in a previous video, but I have spent the time to research that a little more, and now I came up with my own hook there that's nice and simple, not as complex as the full-scale ones, but and it doesn't need to be, because this is a freestyle, as I mentioned, a design here. So I've been trying to maintain some of the aesthetical appeal. It's something that you will see in a real form, but it's got my own MIA microflight features there, and touches the way I like doing things. So stay tuned for those videos coming up next. Thanks for watching.